Okay guys, we're going to do a little bit of binary addition right now to prepare you for your exams. So let me take it nice and slowly. We'll do a bit of a 4-bit addition. So let's just take it nice and simply. Hopefully you can see this. I'm going to go for the number 5 and the number 4, and we're going to add those together. So I'm just going to do this in nibbles. So 8, 4, 2, 1. There's my placeholder. There's my 5. There's my 4. And if I do 8, 4, draw a line in there as well. So to make my 8, I need a 4 and a 1. And to make my 4, I need a 0, 1, 0, 0. I think most of you will get that in terms of made a 5 and a 4. Now, very, very simple. When we're adding 1 and 0, it's dead straightforward. 1 plus 0 is a 1. 0 plus 0 is a 0. The tricky bit comes here, when you get a 1 and a 1. So there's some rules that we need to remember. So I'm just going to whack the rules on this orange post-it here. So, if we ever add in binary and we get a number 2, it really equals a 10. If I ever get a 3, it really equals an 11. Okay? So 2 is a 10, 3 is an 11. Okay, so I've got a 1 and a 1, which is a 2, so I'm really getting a 10. So what I do is I take the 0, place it in my answer, and I carry the 1 over. Okay, so I've carried the 1 over there, and so it's 0 plus 0 plus the 1 that I carried over, which still equals 1. And I should get the right answer because 5 plus 4 was 9, and if you have a look, 8 and 1, that's a 9. Let's try a slightly different one. If I do the same again, and this time I add the number 7 to the number 8, let's say. So again, 8, 4, 2, 1. To make a 7, it's 4, 2, and 1. To make an 8, it's that's pretty straightforward, because what we have is a 1, a 1, a 1, and then a 1 as well. So we get 1, 1, 1, 1, which adds up to 15. Okay? Okay, slightly more difficult example. Imagine if I wanted to add a 9 to a 7. So let's go ahead and do that. 8, 4, 2, 1. So I've got a 9. And I've got a 7. So 4, 2, 1, 0. Everybody got to that point. So when a 1 and a 1 is really a 10. So I take the 0 and I carry this. And a 0 and a 1 is still a 10. And a 0, 1 and a 1 is a 2, so it's really a 10. And then I've got a 1, a 0 and a 1. And I've made 4 zeros and then this 1 extra bit left over, which I can then push up. Now this extra bit here is called an overflow. So an overflow actually occurs when, can you see how I was expecting a 4-bit answer or a nibble answer, and I actually got a 5-bit answer because of the extra 1 carried over? It means that the value that resulted from this operation is actually greater than expected. An overflow usually gets dealt with by the CPU. However, if it's ignored, that one's going to get carried over into other calculations, which will make future calculations incorrect. So you need to be wary of what overflow is, how it occurs, and what are the consequences of not dealing with that overflow. We'll have a look at 8-bit overflow in a second as well. So let's have a look at a slightly more complicated addition. So I'm going to have 128, 64, 32, 16, 8, 4, 2, 1. And instead of using nibbles now, we've started using 8 bits or a byte. So I'm just going to go here. So imagine if I wanted to add these two numbers together. Right, if you want to pause the video here and have a go yourself, you can do. Otherwise, now I'll go through the answer. So 1 plus a 1 is a 2, which is really a 10. So it's 0, carry the 1. 0, 0, 1 is quite easy. It's a 1. 1 and a 1. A 0, carry the 1. Now here's a situation where we've not had before. We've got a 1 and a 1, which is really a 3, so it's an 11. So we have a 1, carry a 1. We've got the same situation here, 1, carry on 1, and now we've dealt with that. So it's a 0, 0, 1, is a 1, 1 plus 0 is a 1, and 0 plus 1 is a 1. So the resulting answer there is 1, 1, 1, 1, 1, 0, 1, 0. Okay, we'll do one more. So if we go for, I won't put the placeholders at the top, we'll just go for a 4-bit number, 1, 1, 1, 0, 0, 1, 1, plus 0, 1, 1, 1, 1, 1, 0, 1. Now, straight away, I know that this will probably result in an overflow, so just watch out for it. So the 1 and the 1 is a 2, so a 0, carry the 1, then we've got 1, 0, 1, 0, carry 1, 0, 1, 1, 0, carry 1, 0, 1, 1, 0, carry 1, and we've got 1, 1, 1, which is really a 3, so it's 1, 1, 1, 1, 1, 1, 0, and here we go, we've got a 1, and we've got to carry, I'll just move that along, there's a 1 that's slipped up here, so there's your overflow there, resulted from adding that one, and that one, which gives us a 3, so I need to put a 1 here, and a 1 got carried here, which needs to be pushed up there. Okay, just remember what an overflow error is. We had 8 bits for an answer, and we got a 9th bit. Now remember, the CPU will have to pick up that error and deal with it somehow, otherwise it will impact the future calculations that happen.